have Wei Chen to share about make a LTS Android OS for industrial devices. Let's give him a big hand.
Okay, good evening, everyone. Firstly, many thanks for Hong Kong Open Source Conference 2024, giving me this chance to give presentation here. And today my topic is about make a long-term support. LTS means long-term support. Long-term support Android OS for industrial devices. It's a very huge topic, so I have to speak up and let's get started. My name is Vic, and my strongest skills are focused on embedded Linux and Linux, Android, BSP. BSP means both support package is for operating system level. And Linux kernel driver development and porting. My current job is work for II Work Group. It's a Taiwanese company. And here's my GitHub and LinkedIn. About online, I would like to classify the customer first, because in the industrial market, so many different kinds of applications. And secondly, I would like to share some important features from Google. And the third part is the most important part in this section is I will share my real experience for this chapter. And this part is about summary. Okay, so let's classify the customer first. Firstly, we have to define the what is the industrial applications. I remember when I touched the industrial domain since maybe 12 years ago, and I thought my job content is focused on the left side, for example, my development device is working on maybe nuclear power station or production line with robotic arm operation or different smart factory. But the truth is over 70% projects are focused on right side, including home automation, point of sale machine, business machine, or kiosk for digital signage. But why they also can be called industrial applications? Because no matter left side and the right side, they have same features. As follows this page, there's two important items, the hardware part and the software part. And there's two items in the hardware part. First one is longevity. It's for hardware components, because in the industrial markets, the device it's not easily to be changed or replaced frequently for the maybe environment limitation. So make sure the hardware components life cycle is very important. And the second, the stability means the customer always have requirement about pass some certifications like ISO or IEC testing to make sure the device is robust. And the second part, the software part, no matter stability, long-term support, system upgrade, and security, it's all related with operating system. And that is today's topic. Before continue discussion, I have one question about, is Android suitable for industrial applications after you saw those conditions? Okay, let's go to the next chapter about the ideal case by Google. As we know, the Android OS is made by Google based on AOSP. AOSP means Android Open Source Project. It's an open source and free download available on official Google official Git server. And there's two famous chip vendor for industrial market. One is Rockchip, and another one is vendor will take the AOSP to make their own Android BSP, and we will take the Android BSP from the chip vendor and the final Android OS for our projects. And right side has a picture. It's from the Google official website. It's Android OS basic architecture from the Linux kernel, health layer, framework and the application layer. And I would like to talk about an important feature in Android history called Android Travel. It's in order to figure out the version fragment issue. So it's a point to separate two parts. One part is before Android Travel, and another part is after Android Travel. So including the hair layer architecture or partition layout is totally different with before Android Travel. And right side has a picture, as you can see, it's referred from the Google website. So actually, Google has entirely planned to support the OS update at least 3 years for consumer device like a smartphone or tablet. Yeah. And I would like to introduce another important feature in Android. It's Android GKI kernel. It's starting from Android 10. And actually, Google want to maintain their own long-term support kernel with Android specific features. So they take the kernel from the NISCON upstream with long-term support version and customize to their own Android common kernel. We call them ACK. And vendor kernel means Rockchip or NSP will take the ACK kernel to make their own vendor kernel. And product kernel is made by us. Okay. And know that after GKI kernel, every Android release is depend on the specific GKI kernel version. For example, you can focus on the Android 14. The GKI kernel version does support the kernel 6.1 and the kernel 5.15. So if your project has long-term support requirement, you have to check the GKI kernel already EOL. EOL means end of life. EOL time already EOL or not. Another case is focus on Android 10. Also, this version does support GKI kernel 4.9, 4.14, and 4.19. But all those three kernels already EOL last year. So it's not suitable for your current project if it has long-term support requirement. I would like to share a lazy way you can check the EOL time. Because the Google is referred from the Linux kernel upstream, you can check on the Linux kernel upstream website and check the latest kernel EOL time. So, for example, you can check the kernel 6.1, the EOL time is December 2026. So it's very suitable for your current project. Okay, so let's go to the most important chapter. It's real case by me. Firstly, I would like to strongly recommend to use manifest and the repo to maintain your Android source code. Because Google adapts this way as well for AOSP. It uses the one of Git features, the Git branch, to separate different Android revision. We can focus on Android 14. It will create a repo folder, and we make a default XML, including the AOSP original XML and the vendor modification and our customization. Combined together as a big one default XML too easy to maintain. And there's over 1,000 repository inside the XML. For example, the device folder, framework base, system call, or vendor folder. After set up the manifest structure, you can use repo init command to download the Android source code with a specific version easily. And remember, don't make all AOSP folders as one repo. Because of course, it's not made by me, but I saw many cases before, so much R&D do this way. But it's not easy to maintain, especially if you have long-term support requirement. You have to update the OS, and this way cannot do that. And if you want to check the old repository status using manifest structure, you can use repo for all command. It's very useful. Okay, so in my experience, I would like to separate two kind of customer in the industrial projects. First one, the customer would like to choose fixed version and have long-term support someday. Another one is choose regular update when latest version announced from Google. It means we need to update the OS year by year. Okay, let's check the first kind of customer. Choose fixed version. It's used for finished machine or door entry system. The pros is easy to maintain because the OS is fixed version. Especially app means this kind of customers always has their own app. So if your OS is fixed, and it means the Android SDK does no need to update for their app as well. But the cons, it's easy to see. It's highly security risk, especially CVE issue. And it will take huge effort if one day they have a requirement to a big jump OS upgrading. And here is the really case by me. We made Android 6 using Rockchip RK33 series platform. And there's 4 customers choose this solution for their project. And after 7 years, the customer 4 has a requirement to update the latest Android. When I face this requirement every time, there's a picture in my mind like this. Yeah, because it's take too much effort and very difficult to figure out it. But it still customer's requirement, so we have to figure out it. If you've got this problem, I list the SOP. You can do this way step by step. First one is checking latest release for the platform. It depends on vendor release. For this case, I have to check with Rockchip. Is 3 series. The latest Android version is Android 10. I talk to the customer, and this task is focused on the OS update from 6 to 10. And the secondly, checking the partition layout is the same or not, because it's impaired with Android Treble as I sharing as previous. And don't forget the APK need to be compatible, because the customer don't want to their app don't work anymore after update the OS. Okay, so let's focus on the partition layout. It's because it's a very classic case. The Android 6 is belong to before Android Treble, and Android 10 is belong to after Android Treble. So the partition layout is totally different. It means you cannot update the OS over OTA directly. So after discussion with the customers, they accepted update the OS using refresh the system way. Yeah. And we also provide self-upgrading over OTA solution on the Android 10 only. And don't forget, if you choose the refresh the system way, you need to retain the MAC address, because sometimes the MAC address is stored in the maybe system partition. And you have to take out and refresh the system and install the Android 10 and restore the MAC address to the system partition or vendor partition. Okay, let's check another kind of customer choose regular update version. It's used for industrial or medical panel PC. But the pros is highly security and always have new functions. Of course, if you use latest Android version. And it's easy to merge commits for cross-version update with a small gap. Yeah. But the cons is about the complexity because you have to spend additional effort and the resource to update the OS every year. That's our real case using ADAMS-A platform and the Roadtrip RK certified ATA platform. We plan to support a regular update since Android 12. And every year we have a new release. So much customers choose this solution. For example, the customer too choose our Android 13 for their project last year. And they have Android 15 requirement next year. We also can provide them because we have planned to release the image every year. And as I said before, it spent much effort at first, but easier later using Gimmerge way because for this case, the Android 12 is the first time to porting. So all functions need to development, so it takes more time. But after Android 12, we just use Gimmerge way to speed up the release time. But not that it still need to face a compatible issue. But effort is very small because Android SDK version is not big jump. Okay, so we continue focus on partition layout. Maybe you wonder why we choose the Android version with after Android travel, we still face partition layout issue because Google still keep improve the Android OS every year. So in this case, we still cannot update the OS from the 12 to 13 over OTA and 13 to 14 as well. But I find out a solution about Android 14 because between Android 13 and the Android 14, they only have one difference about the bootloader partition. The Android 14 is dual bootloader. After I changed to single bootloader, it's the same as Android 13. And it works when I use the OTA update. It means if you continue the partition layout is the same, you can use the OTA update to upgrade your OS easily. Back to our previous case. So in this case, actually we have solution to figure out it. If you change the Android 10 the Android 10 partition layout to Android 6, it will update over OTA. But it will take so much effort, so forgot I say. Okay, I would like to talk about another question about EOL components. EOL means end of life. Because it's easy to happen if you have no any study when kick off a new project. You will face this problem at less than 5 years. And I list the common hardware components which usually EOL are DRAM, different interfaces panel, audio codec, and Wi-Fi module. But if you want to change the new hardware components, you need to report in the driver. It will take the efforts. So, but know that the most important part is you have to keep the release image is compatible for latest device, which you change the components and the earlier device. Okay, so we have a solution to overcome that. I call it dynamic change peripheral solution. The solution one is adopt device tree overlay. Actually, it's a very completed. So I made a solution on Android before and presented on HKOSCon 2020. If you have interest in, you can click the link to see the detail. I just can make the simple introduction here. And device tree overlay is about dynamic change the hardware function and the peripheral on the U-boot stage. You can change the dynamically and for the kernel stage. But in the industrial market, it's not every industrial device can use a debug console. It means you cannot control the U-boot stage. So in this case, I brought the tool named Deep U-boot ENV. It's from the Yocto OS. And I brought it to AOSP. And this tool's feature is it can control and modify the boot argument in the runtime stage for root file system. It means you can use those commands on over ADB. Yeah. But device tree overlay is not enough for some complex function like Wi-Fi or Bluetooth. So you have to dynamic change the peripherals on hair layer. And I share two experience. One is they use legacy hair layer, and another one is latest hair layer. And focus on the legacy hole. First, this example is for GPS module. The old GPS module is based on U-blocks, and the new one is based on Qualcomm. And in the framework part, it has the GNSS service. We'll call the hair layer library. The library name is the fix. So we can tweak the library from the upside to the downside. We can create a fake same library name and load the current, maybe detect the chip ID or vendor ID for your GPS module. And compile the U-box hair layer driver and the Qualcomm layer driver to implement the dynamic loading using DL Open API. But know that legacy hair already been moved from AOSP 14. Okay, so the latest way is use on idle or idle hair layer tweaking. And idle and idle, just like the virtual function in Java or C++ using object programming. If you never touch this, you just remember it's virtual function. And this case is Bluetooth function in Wi-Fi module. The old Wi-Fi module is based on Qualcomm and it's already EOL, and we changed to a new one is based on Broadcom. And the Bluetooth library name is the same. So we can tweak the idle interface. The original interface is used on DL Open as well. So it's similar like the previous one. We can change the idle interface loading behavior using dynamic detect the vendor ID or product ID in the Bluetooth chip. And you can modify the makefile to generate the Qualcomm library and the Broadcom library both support, and using the DL Open to alternative choose the library. And I also want to share some new features in industrial devices using Android OS. First one is FCN API supporting. because in the industrial device, there's no Google Play inside this device. It means we have no passed the GNS certification because it's very huge effort. So we have to find a second solution because the customers always use the push service using FCN API. It's file-based cloud message from the Google server. Yeah. So we put the third-party solutions such as the MicroG project with free open source software app store like F-Droid. After porting, how to verify your FCN API. The lazy way is install the Gmail app and manually to send a mail to test. But it's for internal testing only because install Gmail manually is not legal. And the easy way is you can Google search the FCN toolbox. It can send a broadcast to your target Android device. And our team already verify it works. Another feature is diversity in utilities. Because in the industrial device, so many special interface or protocols like CAN bus, Modbus, GPIO, or RS-232, or PCUA. The utilities depends on specific tools like CAN utilities, Modbus, Squash tool in Linux OS. And we can move those tools to AOSP and compile to as library and SQ command. And you can run the command in Android OS directly. Or you can write the JNI API or health service package inside your app. And you can write maybe a simple GUI to control the spatial interface easily. But the only one thing you have to notice is the utility library's license. You have to follow that. Okay, so let's summarize. Back to my first question about Android. Android actually is suitable for industrial applications, especially HNI means human-machine interface, the panel-based applications. And we can check the conditions one by one again. The longevity in hardware part, we can adopt device tree overlay to overcome the EOL issue. Make one image to support all devices. And the stability part, you can write the test APK. If you face the spatial interface or protocol, you can check back the diversity utilities way to implement app to do your test. And the software part, the stability, because our Android OS is still based on Google AOSP, so it should be no problem. And the long-term support, if you adopt regular update way and the GK kernel, we did. It's support from at least 5 years is no problem. And the system upgrade, remember, adopt after Android travel structure. And the security part, actually, I had prepared a chapter for security in this section, but it's due to time limitation, so I removed that. I just can show you the summary. The Android OS has SE Linux for protect the OS in security function. But in my experience, some industrial customers want to disable the SE Linux. Yeah, but I just like that you know, if you disable SE Linux, you still has DSC rule like the Linux OS. But I still strongly recommend to enable SDNS and trying to figure out the policy issue for your app. Okay, that's it. So thank you so much. If you have any questions, welcome to discuss with me online, GitHub or LinkedIn. Thanks.
Thank you, Rick Chen, for a wonderful sharing. If you would like to discuss with our speaker about this topic, you proceed to the social area outside. The next session will be Hawan Huang at 6 p.m. and he will be talking about open source large language models optimization. We will now have 15 minutes break. Well, remember to fill in the participant survey before you leave.